Welcome back. This is day 2. Yesterday we talked about sequences, but the bigger topic that we're going to cover for this unit is series. And we're starting what would have been a packet in class, but I'll load each of these day by day so you can follow along. But there eventually will be 10 tests of convergence or divergence. We talked a little bit about convergence and divergence yesterday with the idea of sequences. Well, now we're going to talk about series. First of all, we should remind you that a series is not just a set of numbers. A series is a sum of numbers. So you're going to be using this sigma notation quite a bit. So get used to that. Sigma, in this case, means from n equals 0. And again, is your indexing number, your counting number, up to infinity. Geometric series is something that I'm hoping that you're familiar with from pre-cal, because a geometric series, we talked about this yesterday too, as far as a geometric sequence. Geometric series is just the same, generated the same idea, but now we're adding up those numbers. So you're multiplying to get from term to term to term, and you're adding those up. A lot of times we'll be talking about an infinite series where we've got a infinity at the top there, so it's an infinite geometric series. Again, there'll be 10 of these tests. At the end of this, we'll do 3 today. I'll give you a summary sheet that will kind of run down the case for each of those. We're in section 9.3 and 9.4 in your textbook, and instead of assigning book homework, I'm giving you my math lab practice day 1, day 2, day 3. Hopefully you've started to see those in my math lab. It's up to you. If you want to practice, great. If you just want to get the lesson and don't need the practice, well, okay. And away we go. Let's do this one. A geometric series is in this form. So a sub 1, our first term, times r to the nth power, where r is your repeating value that you're multiplying by. That's called the common ratio. You might also start your counter with n equals 1, but look at the coefficient there. It's still going to be, that first coefficient would be 1 minus 1, so r to the 0 power. So you'd have continued to add those numbers. Geometric series is going to diverge if the absolute value of that r is greater than 1. Think about it. If I'm multiplying by 3, let's say, for my common number, I've got 1, 3, 3 times 3, 9, 9 times 3, 27, and then adding those up, well, if I'm adding a bigger number each time, then that series, that sum, is going to diverge. However, if r is less than 1, and that would be absolute value, so it could be a negative r value, if r is less than 1, so really between negative 1 and 1, the series is going to converge. And this is going to be a very important value. It's going to converge to that sum, s equals a sub 1 over 1 minus r, where a sub 1 is your first term, 1 minus r. This is always an important one that we'll see again and again, so I would know that formula as well. Okay, so let's think about it. This first one, it might help even if we start about thinking about the terms here. So a sub 1, what is that? Well, when n is 1, isn't my first term going to be 3 halves? Right? Because when n is 1, you'd have 1 and 2, 3 over 2 to the n, or 3 to the 2. 3 over 2? Yeah, 3 halves. Okay? And then the next one would be 3 over 2 squared, 3 over 2 to the third. Well, that's going to be 3 over 2, 3 over 4, 3 over 8. It looks like we're multiplying by 1/2 to get to each of those terms. So you might even want to rewrite this as the sum, n equals 1 to infinity, of 3 over 2, right, because that's our first term there, times what? 1/2 to the n minus 1. We need that extra n minus 1 because we've got the first n2 in there. But since it starts with n equals 1 as opposed to n equals 0, you got n equals 1. So it's that second form right there. All right? So given the geometric series test, our big question is this series converging or diverging? What is r? R is the number we're multiplying by from term to term to term. I'm multiplying by 3 halves. I'm sorry, 1/2. So that is less than 1. Therefore, we're going to say that the series converges And if we were in the classroom right now, I would say it's going to be very important that you would say by which test. Since my ability to test you like I really would like to might be a little limited, since it's probably going to be on my math lab, I'll go ahead and teach you the formal way, but I would want you to say the name of the test. Series converges by the geometric series test. Notice how you don't have to go all verbosity on us and everything. Just like always, keep it short and sweet. R is less than 1, therefore the series converges. Name the R is, in this case, 1/2. Now, it's also handy if it does converge to calculate that sum. So our sum equals a sub 1, and again, if you expand those out, you can see a sub 1 is 3/2. A lot of times people get confused. Oh, that's 3. Oh, it's 3. Yeah, no. Plug in n equals 1 specifically, and you get 3/2 over 1 minus r. 1 minus, well, r is 1/2. That's 3 over 2 over 1 minus 1/2, there's 1/2, so 3/2 over 1/2 is equal to 3. The series is going to converge to a sum of 3. Okay? This next one, again, a lot of these examples will look similar, but it's not exactly the same. What is your r here? What are you multiplying to get from term to term to term? You need to expand it out. You could do that. When I plug in n equals 1, I get 3/2. N equals 2, I'd get 3 squared over 2 squared, 9/4. Okay, so we've got terms and terms there. But bigger question for you, what is the repeating? What has the exponent? Yep, it's 3/2. Therefore, the series what? Diverges by geometric series test. Okay, so this will be a little departure of what we've been doing. We've been doing integrals and really hard, interesting things like that. Now we're going a little more theoretical math here, so you can do it. Okay, series diverges by geometric series. So a big one. It's test number 1 of, whoops, there it is. Test number 1 of 10, 9 more to go. The nth term test. My email is just buzzing today, yay. The nth term test, this is a big one. It says this: if the limit as n approaches infinity of a sub n, remember a sub n is your nth term, right? The third term, the fourth term, the fifth term, the nth term as n goes to infinity, so that last term. If the limit as n approaches infinity of that term is not equal to 0, then the series of the sum, right? Series is sum again, the sigma from n equals 1 to infinity of a sub n, the sum of those terms is going to diverge. That should make sense, okay? If you're not adding something that's so small that it's practically 0 to your sum, then it's getting bigger and bigger. It's growing, okay? Make sure you put a note by this. If I had a yellow highlighter, I'd mark it. Maybe I'll just mark it with a red pen just to make it stick out. This does not say that the limit, that if the limit of a sub n equals 0, then the series converges. Okay, because the limit of that term could be 0, but it's still adding enough that it's going to converge. There will be other tests that we would need to show convergence, but this is only a test to show divergence. If the limit of a sub n as n approaches infinity is equal to 0, then this test doesn't tell us anything. It's inconclusive. You'd have to use another test. That's why we've got a total of 10 tests. This is a good one, though, to check for divergence. So again, that's why it's the test for divergence, nth term test. Okay? Well, what I'm going to do is take the limit of, this is my a sub n right there. So the limit as n approaches infinity of 2n plus 3 over 3n minus 5. Well, I'm hoping that you're comfortable with seeing that one, right? Isn't that the leading coefficients are the degrees are the same, so the exponents, right? It's going to be 2/3. What can you conclude? Well, 2/3 is not equal to 0. Therefore, the series diverges by nth term test. Okay, notice you're never going to say series converges by nth term test. That's not a valid conclusion. But diverges is certainly a big one that we would want. Okay, n factorial. Well, that sounds kind of fun. I'm going to do the limit as n approaches infinity of n factorial over 2n factorial plus 1. Well, that looks kind of scary, but what if I divided everything by 1 over n factorial? But if I do it on the top, I'd have to do it on the bottom as well. So 1 over n factorial times 1 over n factorial. Kind of like dividing out the highest power, right? We've seen that before. So I'd have the limit as n approaches infinity. N factorial divided by n factorial. Remember, we talked about factorial as well yesterday. That's going to be 1 over, well, 2n factorial. If I distribute this 1 over n factorial, 2n, right, 2n factorial over n factorial. That's just going to be 2 plus 1, if I distribute that, over n factorial. As n goes to infinity, well, this is going to be 1 divided by a very big number, this last part there, isn't it? So 1 divided by a very big number is 0. That 1 and that 2 still survive. So 1 over 2 plus 0 is 1/2. What can we say? Well, it's not equal to 0. Therefore, the series diverges by nth term test. Next one, 3 to the nth. Same idea. I'm going to divide by 3 to the n and 3 to the n, or multiply by 1 over that. So I take the limit as n approaches infinity. I'm taking the nth term. We don't care that it's starting with 1. We're saying at the nth term there. 3 to the n minus 2 over 3 to the n. Well, I'm going to multiply this by 1 over 3 to the n. And multiply this by 1 over 3 to the n. Whatever you do on top and the bottom, that's all valid. So I could rewrite that as the limit as n approaches infinity, 3 to the n, and I need to put my parentheses in here so that 3 to the n cancels out, 1 minus 2 over 3 to the n, over my denominator, 3 to the n divided by 3 to the n is just 1. Okay? Well, that's going to be what? 1 minus what? What's 2 divided by a very large number? 2 to the 3, 2 divided by 3 to the infinity, isn't that 0? That's equal to 1, which again is not equal to 0. Missed my 0 up there, so not equal to 0. Therefore, we're going to say, therefore, the series diverges by nth term test. Nth term, it starts out looking easy. And each of these tests are easy as you go, but when I mix them all together, that of course is when it gets interesting. So it's not, just flip the coin, converges or diverges. You need to do a little bit of thinking here. All right? So there's that. One more test for today, and this is not a real mind-blowing one. It's called a telescoping series. If you think of telescope, those telescoping lenses are the telescoping legs that kind of expand out, but then they push in and kind of compress. Same idea. A telescoping series is called that because it kind of collapses to one term or maybe just a few terms. When you write it out, you'll kind of see the pattern. All right. So telescoping series, and this is test number 3. Determine whether the following series converges or diverges. I'm going to expand this out. So when n equals 1, and again, if it helps you to do this, make a little 1, 2, 3, etc. So when n equals 1, I'm going to plug in 1 for my n. I get 1 over 2 plus 1. That's 1 over 3, right? Minus 1 over 2 times 1 plus 3 would be 1/5. That's my first term. So I'm just going to group those together, okay? Remember, a series there is a sum. So my next term, when n equals 2, I'm going to plug in 2 for n now. 1 over 2 times 2 plus 1, isn't that 1/5? Minus 1 over 2 times 2 plus 4/7, right? 1/7. Plus, let's do one more and see if we see a pattern here. 3. When n is 3, well, 6 plus 1 more is 7. That'd be 1/7 minus 1/9. Plus dot, dot, dot. Well, I bet you can see a pattern here, right? Because this 1/3 is okay, but if I look at the next, minus 1/5 plus 1/5. Okay. So those are going to kind of zero out. And this minus 1/7 plus 1/7. Okay. Those are going to zero out. Now I could write these forever, but that's going to be forever boring, so don't do that. Start thinking. Which term is canceling out? Isn't it the first term is canceling out with the previous last term? And the first term here is canceling out with the previous last term of that. So if you think about that, that's all going to boil down to my first term minus my ultimate last term, 1 over 2n plus 3. Okay? 1/3 minus 1 over 2n plus 3. Well, what we could say then is that if we took that limit, right, it'd be, as n approaches infinity, wouldn't that converge because 1/3, right? So we're going to say the limit as n approaches infinity of 1/3 minus 1 over 2n plus 3. Well, that's bigger on the bottom. That way, if you think of it, that of the end behavior idea is 1/3. Okay, so if the series collapses to a finite sum, that's our finite sum right there. Then the series converges by the telescoping series. It's going to converge to 1/3. Therefore, series converges by telescoping series. Okay, remember. And this is important as you learn these tests. Remember, you're not just guessing. You're not just looking at your calculator and seeing if it's going to grow or not. The series converges here. Make sure that you practice by stating the tests that you're using in your answer as you work those. All right? That's it for today. I'll post some daily work on my math lab as well to practice this. This is day 2, and I'm hoping everything's going well. We will also be incorporating office hour time, so stay tuned for that. And I've posted questions or an update and kind of a reminder kind of thing to get things kicked off on Canvas. Hopefully you're getting your messages on Canvas, so look for those. I've emailed you as well. Please email me back and let me know if you have any questions, and I hope you all are doing well. Have a good one.